team. Let's get started. I'm trying to think what way I like the paper. Maybe this way? I don't know why. I'll do it this way today. Okay. The question for today's do now was looking at the structural isomers again. I gave you the formula C4H10O. With that formula, hello. I said I want you to find the isomers for the alcohol, or the alcohol functional group. There is another type of organic molecule that can form with this formula, but it's not one that I'm going to be assessing you on this year, so I don't want you guys to worry about it. So we're just focusing on the alcohols, and I told you there was a hint, and that hint was there was 4 of them. I figured that was a nice thing to do. Okay? So the way I tackle these questions. So last time we just did an alkane, which is nice and simple because it just had carbon and hydrogens, and all you basically had to do is move the carbons around. Now I've stuck in a functional group. The functional group I've stuck in here is the alcohol, and so you now need to factor that in when you are trying to figure out your isomers. So it's a slightly different technique with that, but same kind of overall goal. First thing I always do is I start with my straight chains because that then helps me give like a little tick box of everything to make sure I have everybody. So straight chain is 1, 2, 3, 4. My other personal preference is now that I have to deal with the function group, I start with the function group on carbon number 1, and then I start moving it around to see all my different functional groups. So I don't know why. I think it's because I'm right-handed maybe. I like to put function groups on the right, but it doesn't matter if you put it on the left because it's both carbon number 1. Are we okay with that so far? All right. Next thing, because it's good practice, I'm going to fill in the hydrogens. I'm okay if you guys, when you're jotting on your piece of paper and trying to plan your structural isomers, to just do rough ones like this. But when you give me a formalized answer, it needs to have the hydrogens there. Okay? So this is going to be H3, because remember, we're filling it in based off the number of bonds I need to meet. So this carbon has 1 bond already, so I'm adding 3 more to get to 4. This one has 1, 2, so I'm only adding 2. This one has 1, 2, only adding 2. This one has 1 and then the oxygen, so that's 2. So 2 hydrogens. All right? The other thing I suggest you do when you guys are learning structural isomers and you're trying to make sure you have them all is to name them, because naming them is a really key way to realize have you accidentally made the same isomer twice. Does that make sense to people? All right. So this is a 4-carbon chain. So parent chain is going to be what? Buch. And then the alcohol is on carbon number 1. So butan 1 all. There's another way you can name it. If you, for example, have another functional group there that needs the suffix, then you can move the alcohol as a prefix, which will be 1-hydroxyl. Butane is the other way I can name that. So both are accepted.
Wait, so that's for what then?
So if you have, for example, another functional group like an aldehyde and you need the suffix for the AL ending, you can't have 2 suffix endings that tell functional groups. So instead what you do is you can take this and move it as a prefix. So, and you'll see some examples like that when you're doing your practice. All right. Next thing I do then is I keep the straight chain and I move the functional group. So this is how I tackle isomers with functional groups. So 1, 2, 3, 4. Alcohol now goes on carbon number 2. And again, I fill in the hydrogens. If I want to double check to make sure I didn't accidentally make the same molecule, I name it. And this is now butan 2-all. We good? All right. Now I just want to show you guys what wrong answers look like, so you know to eliminate them. Let's say I want to move the OH, and I'm moving the OH now onto the next carbon, which is carbon number 3. 1, 2, 3, 4. Oh dear, did not plan on enough space. You can write the OH at the bottom; it doesn't really matter. So when I go in, I might look at this and go, "Ooh, I have a new molecule now because I put it on carbon number 3, right?" But then go to name it. When I go to name it, 1, 2. So it's still butan 2-all. So this is the exact same molecule. It's not an isomer. So this is the same molecule. Not a new isomer. Cool. That's why I suggest you name it. All right. And if I move this onto carbon number 4, do I have any molecule? No, because it's butane 1-ol still. So now that I've worked my way through and I've checked, I moved the alcohol down each carbon, I go, okay, I've maximized all that I can do with the OH. It is now time to start moving a carbon. So you see how I'm doing this as a sequence of events? So I'm going to assume 3-carbon chain now. I basically take off this end carbon. Would I put it on the carbon number 1 on that one? No, because it's still going to be the straight chain. Would I put it on this carbon over here? Would that be a methyl branch? No, because then I still have butane 2-ol. Okay? So I know when I'm moving this carbon that there's no point in me moving it on these 2 carbons. I need to put it onto that carbon there. So we go 1, 2, 3. I'm going to leave the OH on carbon number 1. I'm putting the CH3 here. Again, it doesn't matter in this case if you write it above or below. There will be some instances where it will matter, but I will talk about that later. Probably actually not till we do organic, like done. All right, so that's 1, 2, 3. This has 1 hydrogen here, and this has 2. Cool. And then when I go to name this, what I number it with preference to the functional group, so it's still on carbon number 1. The methyl is on carbon number 2, so I go 2-methyl propan 1-ol. Agreed? All right. So right now I have 1, 2, 3, and I said there was 4. Right? The 4th one is I can't move the methyl because then it's going to go back into these 2 guys, but I can move the alcohol. So I'm moving the alcohol to carbon number 2 now. So 1, 2, 3, OH, CH3, H3, no hydrogen here, CH3. Cool. All right, and when I go to name this, this would be 2-methyl-propan 2-ol. So I personally try to name it. It's good practice, but it's a good way to double check you don't accidentally have the same molecule twice. And those are my 4. Hopefully you guys got that. All right. There's one more thing I do want to kind of point out about this because it's going to help us later in today's lesson. So in today's lesson, what I want us to do is, I'll just point over to the screen. So I want us to start looking at the structural isomer questions from the NCEA exam. If you guys remember, I said that with the unit plan, I want to teach some organic chemistry. We're going to stop organic chemistry. We're going to do spec. By the end of doing organic and spec, you should have an idea, the beginning of organic and spec, you should have an idea of whether or not you like organic. I find that students tend to fall in one of 2 categories. They either really love organic, and it just makes sense. They really love how it's very problem solving. There's not a lot of writing. It's really conceptual. It's big picture thinking. They love it. It just clicks for them. I also have other students where this is never going to make sense to them, and that is okay. That's why I offered 2 externals for level 3 chemistry. There is the organic chemistry, and then there's also thermal chemistry. Thermal chemistry bridges on from structure and bonding, which you guys did last year. And that one is easy to rope learn. So a lot of students like that one because they can just, memorize things. The challenge with that one is that you have the math component again, like you did last year with structure and bonding, which again, some people really love because it's an easy excellence point if you're good at math. Some people really hate. The other thing that's challenging about the thermal chemistry one is that it's a lot of writing. So you can trip yourself up if you don't write enough detail and you don't link things properly. So from my personal opinion, organic is easier to get an excellence on because there isn't that writing component to it. It's just conceptual. So if you understand what you're doing, it's an easy excellence, I would say, as an external. So that's just kind of my doubt. But the flip side is it's harder to kind of get over the initial hump with it because there's so much learning you have to do to be able to do the exam well. And I would say it's actually probably harder to get an achieved on this exam than thermal. If you're trying to just pass, thermal is the easier one to do because, like I said, you can rope learn it. So I want to start showing you guys some isomer questions to get you guys kind of thinking about what organic chemistry exams are like. It's also good preparation for spec because spec is also very problem solving and puzzle like these questions I'm showing you. So you hopefully will enjoy it. But you'll know by the end of spec whether or not this is your cup of tea or not. So in order for me to do that, one of the things I do want to talk about is some vocabulary and things that are going to pop up with how to answer these structural isomer questions. The first bit of vocabulary I do want to add is something called primary, secondary, and tertiary, because when you get these isomer questions, they will give you that as a hint. So primary, secondary, and tertiary is just giving you an indicator of where certain functional groups might be. It applies to ones such as the alcohols, the haloalkanes, and the amines. So you're going to use this terminology in those three functional groups. So now we have an alcohol, so I can start showing you guys that. Basically, it's just a way for us to describe where the alcohol is on an organic molecule. So this alcohol here, what I'm looking for is I want to see the carbon that's directly attached to it. I want to see how many carbons are attached to this carbon. So that's the question. How many carbons are attached to the carbon with the OH is my big question. So when I look at this guy, I go over here. It only has one, this guy. So this is a primary. This is how we call that one. Are we good so far? All right. This guy over here, here's my alcohol. This is the carbon that's directly attached to. 1, 2. So this is known as a secondary. I'll give you the other two examples. All right, this guy over here, this is my alcohol. That's the carbon it's attached to. Look to see how many are attached to that. Directly, not in the rest of the chain. Directly attached to it. 1. So this is primary. Okay. Last one here. Here's my alcohol. Here's the carbon. And then when I look, directly attached to that carbon, 1, 2, 3, tertiary. Okay?
So side chains don't count.
Side chains don't count, no. It's whatever is directly attached to that carbon. Cool. Questions, concerns, comments? All right. Let's take a little bit of a break before I dive into those NCEA questions. I haven't made this lesson pretty nice or anything. It's not officially on Google Classroom yet because I ran out of time. But I know what we're doing. So I want us to do a Kahoot just to kind of make sure you guys understand structural isomers. I have an easy version and a hard version. We can play both if you want. But I'm guessing start with the easy? Okay. Okay. So I have handed out two things to you guys. The first thing I've handed out is this summary sheet from No Brain Too Small. This is how we can identify all the different functional groups. So we've talked about functional groups last week, I think. And that's basically just those different kind of categories of organic molecules. They have certain properties, which is stated on here, or they might react to certain things. And so that's how you can figure out what functional group you have based off of this information. You guys are going to be using this to help you answer this NCEA exam question. Now, I've only printed the first page instead of printing the whole document. The whole document is on Google Classroom, and I have adapted it a bit to either remove some questions or to reformat some of the questions because I'm very mindful that I'm not going to teach you guys esters until after the spec internal. So I wanted to remove those questions. I'm also very mindful you guys haven't done level 2 organic chemistry, and so I wanted to remove some of the ones that potentially could have caused an issue with some of the content I'm going to teach you guys later as well. So that is organized. I've printed the first page because I think it's worthwhile to be able to annotate it when you're starting to look at these questions, just to kind of unpack it. So my question for you guys, I do like to give you guys a chance to do some pre-learning, but I'm also mindful that this could be potentially challenging. There are 1, 2, 3 questions here. So these three questions are basically identifying three molecules. They have given you the molecular formula to get you started. And with that molecular formula, for each example they want you to figure out, they have given you some hints. Now, with these hints that they've given you, you have this resource sheet to decode what that hint means. Now, my question for you guys is, do you want to see an example of me doing the first one, or do you guys want to try to do it first and then no, you don't want to try it yourself? Are you that unconfident? Okay, I'll do it. All right, so let me show you how we decode it. Grab that piece of paper. Okay. So I have been given, have I only been writing in purple pens today? No, I haven't. Okay. All right, so you've been given a molecular formula similar to some of the stuff we've given on the Kahoot. It says that there's 5 carbons, 10 hydrogens, and 2 oxygens there. From that, a number of different constitutional isomers or structural isomers can exist, and they want you to figure out which possible isomers are there. You think that's easy?
I mean, I didn't realize. So that's the first one.
So that's the first hint. This is the molecule. You're doing isomers, like we've been talking about, structural isomers. And then they've given you a hint for each molecule. So this is the first molecule you're trying to solve, the second molecule you're trying to solve, the third molecule you're trying to solve. There's 3 different molecules you're trying to solve. They've given you more hints for each one of the molecules so then you can figure out which one it could be. All right. Some things that I keep in mind before I even start looking at these questions here is I always check the hydrogen to oxygen ratio, because that can give me a hint if there's a double bond. So that's what I always do as my first step. 1, check C to H ratio, because it can give me certain hints and it can tell me if there's double bonds or not. Okay. If my ratio is, I have for every 1 carbon I have 2 hydrogens plus an extra 2. Are we okay with what I mean by that? So if I was to say for this one, 5 times 2 would be 10 plus 2 is 12. So if I had C5H12, it would be that ratio is what I'm talking about. This tells me there's no double bond. If my ratio is 1 carbon to 2 hydrogens, so I just times it by 2, then I do have a double bond. Okay? So when I look at this one here, do I have a double bond? Yes, that's 5 times 2, 10. Not plus 2, so double bond. So that's my first hint. Cool. Keep going. All right. So, any preference to which one I do when you guys read those? Number 2? Does that sound like the most complicated one? Okay. So, number 2 states we have a branch chain molecule. So what that tells me is that I don't have a straight chain. It means I'm going to have some sort of methyl or ethyl group. This isn't a very big molecule, so it's probably going to be a methyl. Are we okay with how I pulled that out? Okay, so I'm just going to write branched versus straight chain when we're looking at that. I should change the color now. So when we're looking at these 2 things here, straight chain versus branch chain, we're just basically saying, do you have like a carbon? Like straight chain is just 1 chain, no branches. This has like methyl or something. I would say it's likely a methyl because of how short that carbon is. It's only 5. And if you guys remember for that do now, there's not a whole lot of ways you can move around your carbons to make branches in a 5 carbon chain. All right. The second hint they've given me is that there are 2 different functional groups. So that's a nice little tricky thing. 2 different functional groups in there. So what that tells me is when we look at all the different types of organic functional groups, carboxylic acid is an example of one that has that C double bond O, OH, But that's a one functional group component. Let me actually pull up what I mean. Let me just get the lesson. Sorry, moving around, just watching our time. We end at 50, don't we? Okay. You get more time on this next week, don't worry. Chemistry, organic. Where did I show it? I think it was this one. Answer. Yeah. Okay. So, these guys here are each a functional group. What that hint is telling you is that you have two of them in one molecule, which can happen. And you guys remember when you're doing your naming and drawing on yesterday? Yeah, no, Tuesday. And last week, remember how we said that, like, you saw how there were some molecules with two functional groups on there? So you're saying you have two of them. Cool. Let's go back to that guy here. These groups cannot react, and then it's giving me some information with the identification test. So something to keep in mind when I'm looking at this question here is when I look at this formula, I have oxygens. So I want to limit myself to thinking about functional groups that have oxygen in there. So if we go back to that image here, like esters have oxygens, ketones and aldehydes have oxygens, carboxylic acids have oxygens, haloalkanes do not have oxygen. So I can already rule out some potential functional groups because they do not have oxygen. Again, I want to pick something that's a combination. So carboxylic acid has two oxygens, but it's one functional group. Alcohol and aldehyde have two oxygens, because it's one each, one from the aldehyde, one from the alcohol, but they're two separate functional groups. So I'm looking for a combination like that. Do you want me to repeat that? Are you okay? No? Okay. So that's what I'm trying to use as a hint. So what that tells me is that I likely have two functional groups that are oxygen-based. One of them is probably going to be an alcohol, and the other one's going to be a carbonyl. It might be an aldehyde. It might be a ketone. I am not sure. But you see how I'm using the information and narrowing down my scope. So this is what I was saying. This is what organic chemistry is like. It's very problem solved. All right, now we are going to this sheet over here to find some hints and to get some information. Some things to keep in mind when we are looking at this is that, like I said, you will not be given this on the exam. This is not part of your resource sheet. You do need to memorize these guys. Okay? So it says here that it will not react with permanganate or sodium carbonate. So I'm trying to get more colors because you know me, I love my colors. So what does that mean? So if I look at this guy here, Na2CO3, I'm basically looking for carbonates, which I hope they've put on here, but they might not have. So let me look on where. Oh, that's really stink. They only just did the Olympus test. I didn't print this in color because I didn't think it was worth printing in color. All right, so they don't have it on here, so we're going to write it on here. So when we think about carboxylic acids, they are acids. So the way we can figure out acids is if we have universal indicator, it goes red. Or the other way you can do it is blue litmus turns red. That's how I know I have a carboxylic acid. There's one more way for us to test for carboxylic acids, and that is with carbonate. So if I add carbonate to an acid, like that, it's going to form carbon dioxide and water. And those are bubbles. So you'll see a bubbling reaction. All right? Questions, concerns, comments? Just as a side note, the other one that you have to be mindful of is going to be the amines, because the amines are basic. Again, if we're thinking about what do we do to identify if something's basic, the universal indicator will go from green to like a blue or like a violet, cooler colors. If I had no, wait, am I thinking about this right? Red litmus, it will turn blue. Yeah. Yes, I'll pop the recording. Okay, so are we okay with that information? All right, so if I go back to the question and we can see that it says that it doesn't react with this sodium carbonate, what that tells me right now is that we don't have a carboxylic acid. So it's just as important to figure out what it is and what it is not. So for my hint for this one is not carboxylic acid.
I thought we knew that.
But we already knew that because it said no, it has two function groups. So it's just reaffirming what we already know, that it's not a carboxylic acid. It's just double checking you. So if you missed it on this one, it gave you another chance to find it, which I think was nice. All right. Then it tells me we have the permanganate question. So I need to look at permanganate here. Again, I haven't printed this in color, but just so you guys are aware, permanganate, when it reacts, it goes from a purple color. So if you guys want to know what color that was supposed to be, that was purple. I didn't want to print it in color. It just didn't seem like a point thing to do. So purple, it would go to colorless if it was reacting. And then the other one you can use is dichromate. It's going to go from orange to green. So if you guys want to know what the colors are supposed to be on that sheet, I didn't see the point in printing it just for those two things. Just write it. All right. So what it's telling me is that it does not react with the permanganate, and what the permanganate tells me as information is that there's a lot of different things it can tell me. First off, it can tell me that it's not a primary alcohol. It also can tell me that you don't have an aldehyde. All right, what else can it not tell me? It also will not react, it's not a secondary alcohol. So if you go back to the do now, it gives us hints of where the alcohol is. It also tells us it's not an aldehyde. So when I'm looking at this guy here, I can see that this is primary, that's secondary, that's primary, that's tertiary. So from that information there, because it doesn't turn from purple to colorless, it tells me you don't have a primary or you don't have a secondary alcohol. So you must have a tertiary alcohol, because that won't react. You want me to repeat that? Okay. So the permanganate here, not reacting, because it says it cannot react, it then tells me, okay, you don't have any of these three things in your molecule. Okay? I do not have a primary alcohol. I do not have a secondary alcohol. So we know the alcohol isn't on carbon number 1. It isn't on carbon number 2. It's going to be doing something like this, which is a tertiary, because those do not react. So I can have an alcohol that's tertiary. It will not react with permanganate.
Because it says have a reaction.
Yeah. So there's no reaction. So what this tells me as my next hint is that I probably have a tertiary alcohol, which double checks myself, because you see how it said that this is going to be a branched? And in the tertiaries, we have branches. So that makes sense. The second thing it tells me is that we don't have an aldehyde. So if you guys remember when we were doing the hints here, we have a double bond, and what that tells me is the double bond is not an aldehyde. So it's probably a ketone. All right, now we gotta draw a 5-molecule component with a branch that fits all those criteria. So let me get another piece of paper. All right, so first thing I'm thinking about when I look at this information is I have 5 carbons, but I know it's not straight chained. So I'm gonna assume 1, 2, 3, 4. Carbon is on carbon number 2. Doesn't matter if I put it over here or over here, because it's still going to be a branch. So that's met that requirement over here. It is branched. Second thing is that it's a tertiary alcohol. So what that tells me is that you don't have the alcohol on this carbon, or this carbon, because if it's on either of these 2 carbons, it's primary. If it's on this carbon, it's secondary. So it must be on this carbon here. All right. So now I've ticked 2 of my requirements. I've gotten it branched, and I've gotten the tertiary alcohol. Last component is I need to figure out what to do with the other double bonded oxygen, which is my ketone. Again, it's going to not be on the end carbons, because if it's on the end carbons, it is an aldehyde. And we know based off of this information, it doesn't react with the permanganate, so it's not an aldehyde. I only have one place to now put this guy, and it's over here. It looks like I don't like this. Now I just fill in the hydrogens. 3. That one, 1, 2, 3, 4. You're done. 1, 2, 3, 4. You're done. This one, 3. I'm just gonna put dashes in there because then it makes it look like it's one piece. All right. To double check myself, to idiot check myself, I'm gonna go through and count my primary school. Make sure I have 5 carbons. 1, 2, 3, 4, 5. That matches. I need to make sure I have 2 oxygens. 1, 2. That matches. And then I need to make sure I have 5 hydrogens. 3 plus 3 plus 3 is 9. Plus 1, 10. I've done my molecule correctly. Questions? Yeah.
Do you know like for the CH, 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 or anything? How come you put on the middle two?
How did I put what on the
CH, the hydrogen.
the hydrogens? So the reason why is because with the carbon, it can only have 4 bonds. So this carbon here is bonded to that carbon. It's also bonded to that carbon. So that's 2 already. And then it has 2 bonds with the oxygen. 3, 4. So there's no need to add any extra hydrogens. This one over here, 1 carbon, 2, 3, 4. Don't need any more hydrogens. So hydrogens are just a filler. Okay? That's a molecule. Can I name this for you guys? Maybe. Yes, I can. How do I name that? You want to try naming it? Yeah, go for it. Go ahead and try to name it. Got a few minutes left.